Okay, so for section 6.4, we're going into exponential growth and decay. We briefly talked about exponential growth and decay when we were graphing. Remember, growth goes away from the axis, decay goes towards the axis. This section is really going to be dealing with application problems. Applications. All right, so what you always have is you always start off with 1, which is 100%. And then if it's growth, you're going to add a percent. That's the rate. And it's going to be written as decimal. So 7% would become 0.07. And so that would be 1.07 to the t. Okay? And so decay, you, again, would subtract the rate. And let's say 5% would be written as 0.05. And so 1 minus 0.05 would be 0.95. Okay? T represents time, and A represents how much you start with. So A is the initial balance, or initial. It's your y-intercept, or the initial amount. R is rate. You need to write as decimal. And T stands for time. Okay, all right, so we're going to do some of these. You definitely have to have your calculator for this, for some of them. Not yet, but we'll see. All right, so determine the function represents growth or decay, and then state the percent of growth or decay and the initial value. All right, so to find out if it's growth or decay, we look inside. 1.03 is bigger than 1, so this is growth, and it's 0.03 above 1, so that's 3% growth. And the initial value is the A value, so the initial amount of money was $2,000, if it's talking about dollars. All right, here we look inside. That's less than 1, and that's decay. And so to find out what the decay is, I subtract it from 1. And so it's 13% decay. And then the initial value is 2.48, because remember, initial is the A value. All right, 2.3 is definitely bigger than 1, so this is growth. And so 2.3 minus 1.0 is 1.3. And we have to write it as a percent, so that's 130% growth. And then the initial value was 14,200. All right, and then the last one, we look inside. This is less than 1, so that's decay. And I do 1 minus 0.7, so 0.3. So that's 30% decay. And then we need our initial value. And our initial value is 5,000. Okay, so inside the parentheses tells you whether it's growth or decay, and you subtract from 1 to find out how much above or below 1 it is. All right, so now let's do something called compound interest. So interest sometimes is compounded more than once a year, and when it's compounded more than once a year, we're going to use this formula. And it's compounded in this formula n times per year. So A is the initial amount, which is also known as your principal. R is your rate. Remember to write it as a decimal. N is the number of times per year. So if it's only compounded once a year, you can plug in 1, but it really doesn't make a difference. If it's just 1, you leave it there. And then T is time. All right, so let's go ahead and plug it in this formula. So compounded yearly, this is compounded yearly, so N is 1. So I start with 1,800, and it's 1 plus 0.06. Because it's one time a year, 0.06 divided by 1 is still just 0.06. But I do have to raise it to the 15th power. And so now you just take your calculator, and you do this. Plug it in. And so after 15 years, you will have $4,313.80. Okay, let's go to the one underneath it first. So I start with 1,800. I'm adding 12%, but this is compounded monthly. So n is 12. So I have to divide by 12 here. And then I have to raise it to the power of 15, but here's something that's important. Whenever you compound, you also have to multiply the time by how many times it's compounded. So it's going to be 15 years at 12 times per year. So now, once I have that, I could just use my calculator to plug it in. And so after 15 years, you're going to have $10,792.44. Okay? All right, here, this one, I wanted to save this one because I have to move my decimal 2 places, so it's 0.0881. Quarterly is 4 times a year. This one is going to be 0.075. Daily is 365. So I'd like you to plug those two in, and then when you think you have it, go ahead and press play. Okay, so this is what you should have had. And when you plugged it in, you should have got $6,652.17. And then here, same idea. Divide by 365 and then raise to the 15 times 365. And so you get $5,543.75. Okay? So these aren't necessarily tricky. You just have to be careful to remember that if you divide by compounding, you also put that in the exponent. Remember, if it's growth, it increases and it's a plus inside. If it's decay, it decreases and it's a minus inside.